Okay, welcome back. For this video, I have to explain all about the pet footing design that I have analyzed in my plan. Okay, and then for the pet footing design, which is placed on the bottom of the critical column, which is we need to identify the total axial force and which is transferring n from the critical column at the top. Okay, we take the value, the total n from each floor, we total up and then we got this value. And then for the column size is like the same. Okay, 200 times 200 millimeter, and then we use FCK and FYK. Okay, and then for the difference of this calculation from others, because for the pad footing, we need to identify the soil bearing capacity. Soil bearing capacity is the actually is capability of the soil to resist the load that transfer from the top, which is from the building. Okay, if the soil bearing capacity is high, uh, it means that the soil is quite strong to resist all the load transferring from the top. Okay, if the soil bearing capacity is if the value of soil bearing capacity is small, it shows that the soil is weak, can't resist the lot of loads that transferring from the top. Okay, and then we proceed to the soil bearing capacity calculation. Okay, and then we for the soil bearing capacity, we have take this value from the borehole test. Okay, borehole test. Okay, BH1 and then borehole test 2. Okay, BH1 and BH2, we got from the SI report. Okay, soil investigation report, and then from the n value, n which is blows, we got 60 blows for the BH1, and then for the BH2 we got 10 blows in for the soil. And then from this n value, we need to calculate the shear strength CU, which is we need to use this formula 5 times n. Okay, and then we got like 80 and 50, and then we need to calculate like QD. QD is use formula 1.3 use NC. NC, what is NC? NC is actually the Terzaghi formula. Terzaghi formula that we need to referring for the latest one, which is the value is 5.7. Okay, and then we got this value, and then we need to calculate this average of these two value. Okay, we got this, and then we need to calculate the soil bearing capacity. Qall is Qall is soil bearing capacity using this formula. QD average this, and also we need to divide it by factor of safety, which is we take 3. And then this value we need to divide by 3, and then we got the soil bearing capacity 160.55 kilonewton per meter squared. Okay, after we got the soil bearing capacity, we need to proceed the calculation of pad footing. We need to identify the C norm. Okay, we got 35, and then we need to estimate the footing size. Okay, we need to determine the SLS, which is service load. Okay, service load, and then we got this. We need to divide it by 1.425. What is 1.425? 1.425 is actually the factor of safety. These two factor of safety, 1.35 plus 1.5 divided by 2. We got this value. Okay, and then we got this SLS load. Okay, and then we assume 10% from SLS, and then we got 50.82, and then we got the total SLS. We got this value, and then the area of footing required, we got this. Okay, we need to divide by soil bearing capacity that we got at the top. Okay, we got this. This actually we need to know this to identify, to determine the dimension of the footing that required for the pad footing. Okay, and then we need to square root this value. We got 1.04 meter. And then we provide 1.5 times 1.5 meter of square footing. And then the area provided is 2.25. We need to times this two value, and then much larger than area required. Area required is actually area required this. Okay, and then we need to check the it is suitable or not. Okay, we need to check the effect of footing. Then we need to check the surface soil pressure. Okay, soil bearing capacity must be larger than this value pressure, and then we can use the H is 0.5. It is okay. Okay, we need to proceed for the loading analysis, and then we calculate the ULS. We got this, and then we need to calculate the soil pressure, ultimate load P, and then we need to calculate the soil pressure per meter length W. Okay, we got this value, and then we calculate the bending moment IC. Okay, and then using this formula IC, and then we got this value, and then we need to calculate the maximum moment MED. MED we need to use WI squared over 2, and then we got 31.74. It is a maximum moment MED. And then for the main reinforcement, and then we need to calculate the D effective depth, which is we got 45, and then we need to calculate the K. Okay, then value is lesser than K balance, so compression reinforcement is not required. And then we calculate the Z, okay, and then we can calculate the S required. Okay, we calculate the S required, and then we calculate the S min, S max. So the S required, we provide a 4H20. Okay, so then the S provided is between S min and S max. It is okay. And then for the vertical shear, VED, for the VED we calculate, okay, using this formula PAV. Okay, we got this value, and then we calculate the shear resistance VRDC. Okay, like the same as the other design. Okay, we need to find the K and P1, and then we calculate VRDC, and then we need to calculate Vmin. So this between this value, the larger value is we pick as the VRDC. Okay, VRDC we choose Vmin, and then VED is smaller than VRDC. It is okay. And then we need to proceed to punching shear, and then the critical parameter U. We need to calculate this formula. Okay, we get this, okay, this value, and then critical area. We need to calculate the punching shear force VED, and then punching shear stress VED, and then we need to calculate the shear resistance VRDC. Okay, and then we need to compare. We need to compare VED, this VED, okay, VED, this value of VED. We need to make sure that the value is lesser than VRDC we get. We get VRDC 0.45, larger than this value VD, and then it is okay. And then we need to calculate the maximum shear resistance VRD max using this formula. Okay, so we get 10. and then we calculate the maximum shear stress, VED max, maximum shear stress as the. Okay, and then we got a 0.65. Then the value of VRDC max must be larger than VED max. So the shear resistance, shear that can resist is larger the value from the shear stress that push. Okay, so it is okay. VRD max is larger. Okay, and then cracking. For the cracking, as mean, we need to find the value, maximum value between this value. Okay, and then diameter bar we need to plus with 5 dg, and also with 20, and then 25 is the larger, is the maximum, and then we need to calculate the fs using this formula. Then fs we need to use this formula, and then we calculate fs. Then we got 27.79. Okay, after we calculate fs, and then we must check for spacing, and then we got the value of spacing is larger than the allowable spacing, which is 300. Actually, at first our design is failed, and then we need to do some amendment, which is we need to change the main bar. Okay, we need to change the main bar to 6H16. Okay, so we need to calculate like the same as this, and then we get the value of maximum bar spacing is lesser than 300, and then it is okay. And then the detailing, this is the detailing of pad footing, which is we use the new reinforcement that we designed, which is 6H16. Okay, this is the plan view, this is the stump, and then this is the cross section. Okay, and then that's all for design pad footing. We proceed to taking off pad footing and stump. And then for pad footing and stump, we have to consider for the excavation. And then for the excavation, we have a 3 level. First, we need to excavate for the topsoil, and then we need to excavate for the depth of 1.5, and then if the hole that we need to excavate is more than 1.5, we need to proceed to the third level, which is depth of trench is more than 1.5. Okay, and then we got this value that to excavate, we need to total up this value to calculate in the BQ. Okay, and then we need to analyze for the concrete. Okay, we got this, and then we calculate concrete at the stump that used for stump, and then we got this value. And then for the lean concrete, okay, for the information, we use pad footing, we use a grade concrete of 35 because of we need to use a higher grade of concrete for the pad footing, because pad footing is actually the structure, the most bottom of the structure, that we need to make sure that the pad footing can resist all the loads from the top. So we need to use the higher grade of the concrete. So at least we use 30 G30 grade 30 of column of concrete. So for this pipe footing, I have used G35, which is FCK 35. Okay, and then we need to proceed for reinforcement. Okay, we use reinforcement 6H16. Okay, we calculate in pad footing, in ties, we got this value, and then we need to calculate value in stump. Actually, in our design, there is no design for stump, but I assume that my pad footing my stamp is use this reinforcement. Okay, and then we need to use link. Okay, R8. Okay, and then we need to calculate for formwork. We need to sum up all the value based on each materials, and then we need to calculate in VQ, bill of quantities of foundation and stamp. And then I have do some research for the excavation, the rate of excavation, the latest. Okay, latest rate of excavation, which is the latest is at 28 July 2020. Okay, this is the rate of the excavation, which is RM 19.1930 cent. Okay, for each meter cube. Okay, and then for the all this material is also the latest price that I have to do some research. And then total bill. Total bill actually I'm not calculating yet. Now I have to calculate. Okay, wait some minute. Actually, I just want to show to all of you how to calculate the BQ, which is we need to sum up all price, all this price, okay, that we used for to in construction in constructing of pet footing. Okay, and then after I have sum up all this price, I have get the total value for total bill of this only pet footing, uh, which is RM 616.40 cent. 40 cent. It is actually is quite higher. Actually, it is quite expensive. Okay, to analyze that one each foundation and stump is actually value is until 600 RM 600 plus plus. Okay, it is actually it is quite higher because yes, as we know that the uh, at this era, okay, the price of house is actually more will increase, okay, based on the time. So it is a logic that the price of one stamp is 600 plus plus, okay, 616. So it is okay. Okay, I think that's all for my BQ and my taking off, and also my design for pet footing, and also the other design that I have prepared for from the previous videos. Okay, I hope did you get something, and did you get the input. Okay, and then okay, and then that's all from me. Thank you.